Okay. All right. Ladies and gentlemen, looks like my microphone might be out of batteries. Maybe we can replace that when the attendant comes back. Maybe not. In the meantime, I'm just going to be projecting as much as I can until my voice gives out. We'll see how long I can last. But welcome back to another week of EECS 440. It's going to be a short one, at least as far as lectures are concerned. But you have plenty going on right now, don't you? So, not long ago, a couple assignments came due. Which ones? Can you remember? Yes.
AR and VR tutorial.
Yep, that's right. Tutorial AR, tutorial VR. Not the easiest assignments in the world. They are a little bit lengthy. Okay, you're doing a lot of things. And the goal for this past week has been to get you as much time in Unreal, in Unity, as possible. Okay? Get you in the headset, get you into your device, okay? Deploying apps, something that maybe you haven't done a whole lot of before. There's a very good chance you experienced some friction this week. Did you? Raise your hand, right? You had some weird Xcode issues. You had some nasty, annoying meta issues. Of course, right? EECS 440 starts up and Meta just happens to release a horrible bug to their headsets. I mean, isn't that just the XR experience? But a reminder, this is the kind of stuff that is annoying to you, but if you get through it, it will wipe out your competition. Okay, I'm telling you, the easier you have it, the easier all of your opponents have it. Okay? So, just keep that in mind when the going gets tough. It helps me keep at it the very least. All right? So, let's make sure we're streaming. It looks good. I'm going to turn my mic down so I don't get clipped. So, it's going to be a pretty fun lecture today. I hope it has a chance. It's kind of a risky lecture because it's going to be a workshop. We are going to be programming up here together in Unreal in a pretty major way. I'm going to be showing you one of the most important design patterns in all of game development, probably in all of XR development as well. We're going to be showing you what's called the affordance interaction design pattern. And it's going to make it really easy for us to add little bits of interactivity logic to anything in our virtual environments that we want. If we want to make a light switch that toggles the lights on and off, that is going to be a 30-second thing. If we want to make a interaction that allows us to exit out of the door, or an interaction that allows us to move an object just by pointing and clicking at it, or an interaction that allows us to pull a fire alarm. This design pattern is going to make that very, very nice. And I can already tell that, like, without this mic, my voice for game engine architecture tonight is just going to be totally shot. I'm going to raise the front desk. I hope they don't mind. And I'm just going to kind of, let me see here. There we go. I'm just going to kind of snag the replacement battery here and hope it's charged enough. But that's what we're mainly going to be doing today, and it's going to take up most of our time here. I say it's risky because every year Unreal Engine finds new ways to break things, and they rename a lot of stuff. And so I hope I can get through it completely, otherwise we'll have to finish it early next week. This is an extremely important lecture for your Project 1 because you can watch it and follow it to get a lot of your first week's work done. Okay, very nice and simply. So that's another big thing happening today. We are launching your Project 1. How many of you wanted to form teammates and you've remembered to hop into the team together? Every single semester we have, is it coming out of there? Can you hear me? Okay, no, it's nothing. Even when I turn it on, it's not working, huh? Wow, what a bummer. That's pretty gnarly. Yeah, usually it works just fine. There's a sync button on here. Testing. No? turn it off and turn it back on again. Don't know what else to do. Testing, testing. Oh, hey, there we go. All right, and so remember, if you wanted to have a team, you had to go onto Canvas and jump into a team with someone. You have to actually do that. Otherwise, tonight, you're going to end up getting a random teammate assigned to you. That is not a problem. That is something you can do. It often goes very well. But please do not email me tonight saying, oops, we forgot to hop into that team we wanted, because there's a very good chance you will not get your team. All right? Okay, I want to show you a quick company as well, Vicarious Surgical. So we've seen that you can actually use virtual reality to get out of having to use anesthesia. And there are some medical benefits that can provide, as well as cost benefits. And so here is another interesting company that is trying to use virtual reality along with a little robotic device to make small operations a little bit less invasive. And so, minimally invasive, maximum expressiveness, maximum freedom. Vicarious Surgical Robotic System is designed with a focus on abdominal access and visualization through a single port. And so here's the idea. We'll go ahead and take a look. 2 minutes.
Hello everyone, I'm Stephen Frum, CEO of Vicarious Surgical. Over the past year, Vicarious has moved through one of the most demanding stages of any hardware company's life, turning bold engineering ideas into a surgical platform that can perform with precision, safety, and reliability. This phase is rarely visible from the outside. Starting this month, we are changing that. Our goal is simple: to make the development of our platform more transparent. Innovations in robotics, particularly in healthcare, is not linear. It involves steady progress, course corrections, and hundreds of technical decisions that shape the outcome. By sharing both our advances and our challenges, we hope to give investors, partners, and clinicians a clear view of how true surgical innovation is built. You can expect regular updates as we move toward design freeze, short posts, videos, and educational features that explain what we're learning and why certain steps matter. We'll discuss topics such as why builds must be conducted under controlled conditions, how our quality management system ensures repeatability and compliance, and what each development milestone really means. Some of these updates will take the form of interviews or behind-the-scenes footage. Others may rise to the level of formal press releases when they mark key program milestones.
A strange video. It doesn't really talk about what the product is. It talks about how the team is doing, which is very strange. But you can kind of see from the footage that this is how the device works. You have this tiny little robot that is kind of like the size of a large pen. And it comes with lights, and it comes with two arms that have little grabbers on the end and can be manipulated by a player, by a person who often has a VR headset on. Though I don't think they showed the VR headset in this particular bit of footage. But the idea is that you can send this robot someplace and you can do operations over the internet. For instance, if you can't get a professional, a doctor, to some remote place, they might still be able to do a surgery remotely using this robot. Even if they are in person, this robot is extremely small. So the idea is, if it's a really small robot, we don't have to open up your entire abdomen to be able to operate in there. We can put the robot in through a tiny hole. A tiny hole means that there's going to be a much nicer, faster healing process. There's less risk for damaging other parts of your body. So, yep, lower costs, less risk, all that good stuff. I'm sure innovations like this means all of our healthcare costs will go down a lot very soon. Okay, this is kind of like when we shrink the size of our course staff from 4 people to 2 people, and I say, oh good, the students won't have to pay as much tuition soon, right? And you know, that never happens, unfortunately. But anyway, we can hope, can't we? So you've got this tiny device and you control it through these controllers. I think I've seen that they can work with VR controllers and a VR headset. though it's not quite emphasized that much in the current version of the website. I've never seen this video before. It is interesting to watch these companies, check in with them every semester and kind of see what they're doing. In any case, I'm glad that they haven't gone bankrupt. But anyway, you saw that is this company launched yet? Is their product really out there? Are they selling copies? No. So a team like the previous Wide Awake VR that already has their product in the field, already being used on actual patients, that's very nice, isn't it? It gives you a lot of confidence. It's already out there, right? A company like this, did you see them operating on real deal humans? Was it there? Did they have any footage? They had some stuff that looked vaguely like realistic, but most of it looked like testing, right? How do you feel about a company that has been around for years, but their product just isn't out in the field yet? The company is releasing videos telling you about their development process and research process, not about their sales. How do you feel? Yes?
I feel that they're taking a lot of time to develop, but that potentially it might not actually result in anything tangible.
Yeah, like it's starting to get a bit dicey, right? Like, are there some problems we don't know about? Because, you've been around for quite a while and the product isn't released. I know, you've got to get some medical approvals and stuff, but Wide Awake VR had patients, within the first year or two. What's the problem? What's the holdup? Maybe there's something we don't know. So that's something that you want to consider, okay? This course is very much about VR and AR, but let's not kid ourselves. When it comes to new technologies, there's a lot of fraud out there, okay? There's a lot of empty hype, and you really want to develop a sense for seeing through that kind of stuff and for asking difficult questions, okay? We care about genuine, clear, actual, current use cases. And often what we find is a bunch of groups and companies that are all hype. I'm not saying this one is, but it is actually a lifestyle and a business plan to make a pretty presentation and a beautiful website, to get dumb money, dumb investors to give you money, enjoy a rich lifestyle in a beautiful city, and then bankrupt your company and move on to the next idea. That is a genuine lifestyle for people, basically burning investor money. And it makes me really sad because there are really, really great teams out there with excellent ideas who can't get money because it's going to a bunch of fraud. Okay, anyway, I'm not saying that this is a fraudulent company. I think their product is very cool. Anyway, an interesting use case for VR. Let's hope that they can get this thing out and actually start having genuine impact with it. Okay, $185 million in funding from Massachusetts. A lot of interesting medical technology, biotech. I have heard time and again that Boston is the place for this kind of company. So if this kind of intersection of topics interests you, medicine, very impactful, and technology, then Boston's a good place to be, the East Coast. Ann Arbor's a pretty good place to be too. Okay, a really fun thing that I heard. You've seen this before. Like, this is Horizon Worlds, Meta's kind of competitor to VR chat that isn't doing very well. It's getting blown out by VR chat, last I heard. This app has been kind of infamous for designing avatars to not have like lower bodies. Do you know why? It was suggested to me not long ago by one of the Ann Arbor game studio heads that there's a kind of a funny reason why lower bodies were left off of these characters. You might think, well, there's not enough processing power to deal with legs, right? And animation and the kinematics, inverse kinematics of making legs and walking look good. It's like, yeah, okay, these are mobile headsets, mobile chipsets, so that kind of makes sense. There's another reason, probably a much better reason, that Meta decided not to include the lower half. The lower half of a human body is also what?
It's not tracked, that one.
Yeah, it's kind of hard to track the legs, but do you really need to track the legs accurately? to make a decent thing. VR chat has lower legs for all their characters, right? What's another reason that a, advertiser-friendly company like Meta might be incentivized to exclude the spicier half of the human body? I just said it, right? If you remove the lower half of the human body, you have gotten yourself out of a lot of difficult moderation questions, okay? Do you know what my first experience with VR chat was? I got my first headset and I was, oh, this is such a fun headset. I'm really impressed by the immersion. I'm going to open up VR chat. I keep hearing things about it, and I heard it's a bit crazy. Let's see what's going on. And I spawned into this map that's like kind of like this club. And it's very moody. It's raining outside, neon lights. It looks really cool. Got some jazzy music playing. I'm on the first floor, and there's no one here on the first floor. It's like a bartender or something. That's kind of cool. I wonder where all the people are. And I kind of like warp my way, and I'm going up some stairs. And I like peek over the edge. I start hearing strange growling noises. And I look over at the far corner of the room, and I see a bunch of furries doing some very interesting poses in the corner of the room. And I think, oh, okay, all right, well, excuse me. And I head the other direction. And I can't, that's definitely not my thing and not the experience I wanted, but it definitely felt like a very human moment. In similar, has anyone ever had a experience with Gmod, Gary's Mod? Right? The kind of things you can find in Gary's Mod is like, whoa, okay, this is a little bit crazy. And I want to just put this idea in your head that when Mark Zuckerberg designs his software to be as advertiser-friendly, sterile, safe as possible, he is very intentionally excluding some very important elements of what makes a human being a human being. Okay? Humans are not these clean creatures. We are a bit crazy, a bit unpredictable. At times we're very wholesome, and at times we're very spicy. Okay? And that's the kind of stuff that makes humanity interesting and exciting. And when you exclude those things, you are making a product with no appeal. Appeal to advertisers, but no appeal to actual people. Okay? Well, the rest is history. No one wanted to hang out in this kind of environment. If you play games, like actually engage with games like Roblox, Gary's Mod, if you go to steamy and weird and crazy places, and sometimes quite, spooky places, like 4chan, okay, like some subreddits, you will discover that the mischievousness, okay, the things that, probably shouldn't be there, are a big reason people go there, all right? And so, big companies, sterile companies like Meta, will always have weaknesses in places like this. Keep that in mind, all right? Okay, so anyway, compare what Zuckerberg was building to the gorgeous, beautiful, yet way too sterile dystopia of a universe like Mirror's Edge, where the future is a beautiful, exceptionally boring place to be, all right? It's kind of... remember that like SpongeBob episode where Squidward discovers his paradise? And he very quickly discovers how awful it is, right? For everything to be perfect. It's very interesting to think about. Okay, XR lottery is not a thing, and it's because this semester Microsoft killed our entire supply of VR headsets. So talk about XR pain. Microsoft retired the Microsoft Windows mixed reality platform, which all of our course headsets supply uses, which means I could do the equipment lottery, but you would just have a bunch of paperweights. So, not so great, huh? We'll have to wait until an open source replacement comes out. Someone who loves those headsets is going to be working on it. And when that comes out, we can redeploy those headsets. In the meantime, we're all going to be using either any MetaQuest devices you might purchase yourself or these wonderful headsets in here. It's not the worst fate in the world, but it is a bit annoying. I appreciate your patience. But again, welcome to XR development. We have new annoying things popping up every single year. Okay, You can check out MetaQuest 3 headsets, good headsets, very useful. These will still work. From Groundworks. Groundworks is right across the hall. They've got more than 9 headsets available for you to check out. First come, first serve. If you want to do your Project 1 from home, rock and roll. Okay, go get some. Let's talk a little bit about your Project 1. Project 1, this is your first major assignment. I'm not saying it's going to be harder or more laborious than your Tutorial 1 and Tutorial 2, but it will be very big, real deal things. So let me see if I can plug this in. Whoa. Feedback, I think. Okay, just a moment. There are no slots. Let's do, can I unplug this? I'm not going to risk unplugging anything. I'll just tab it with the arrow keys. So, Project 1. This is going to be your major virtual reality standardized project for the semester. You will be in Unreal Engine. We'll be building some very cool stuff. This is going to be a project that is inspired by a very famous virtual reality game. One of the first big VR games to explode in popularity. It's called Job Simulator. Okay, it has quite a few reviews. It made quite a bit of money and was very well known in developer circles for the interactivity it brought to its environment. In this game, you go into a bunch of environments from the perspective of a future that is a utopia run by robots who would like to remember what it was like for humanity to do menial jobs, okay? In the future, people look at office desk work as a relic of the ancient past, and robots try to recreate the experience for the pleasure of visitors. Of course, they mess it up, and they don't quite understand what humans were doing, and that's part of the game's humor. Let's take a look at a trailer for the game. You'll get a feel for what the game is about.
Hello, human. Welcome to an accurate simulation of office worker. Time to jump. This looks like it'll taste interesting. Delicious.
Oh no, the boss bot is coming. Hey, you've been doing a good job.
Looks like I've got some money to blow. Shred everything for legal reasons.
Today's not your lucky day, pal. Open that safe.
Holy smokes, this is way too hot. You've been doing a really good job lately. I think it's about time you got a promotion.
Hooray, it's 5 o'clock. Woohoo, it's time to go home.
Yeah, I'm gonna have to ask you to come in on Saturday.
Right, so we have this kind of playful, kind of comedic satire take on the role of an office worker. It is often kind of making fun of the kind of meaninglessness of cubicle work. And it is a very, very interactive environment. When you look at just this one screenshot, right, one view of your surroundings, you can see a lot of things that are interactive here. Big buttons, a screen that shows you different things, games, emails, stuff like that. Calendars that can be interacted with, a phone you can pick up and talk to people with, objects you can throw, objects with different physics, like this airplane. A character you can talk to, your cubicle mate leaning over annoyingly the desk, right? This is an environment that is extremely interactive and rich. When you get into this space, it feels alive in a way that other spaces don't because of all the things you can do. It is very, very dense, okay? And that was a lot of the appeal. When a game like Job Simulator comes out, you can sometimes kind of wonder what the purpose is. Yes, to help people have fun, but these kind of games also often have an artistic purpose. When you make a game about being in a cubicle, you are making choices about how to represent that. Do you have a fun time existing in a cubicle? Do you think it is a natural place for a human being to be? Right? This is a satire for a reason. And when you go to recreate a laboratory on campus in this Project 1, you are, in a way, telling people about what it was like to be a student at UMich, a computer science student, in 2026. The choices that you make, which characters will you include? What will they say when you interact with them? What kind of interactivity will you add to this space? Will it be a stressful experience or a relatively calm one? That's up to you. And the choices that you make will, be seen by people in the future. People will have a chance to play the games you make in the future. They'll see the footage you release of your project, and they'll learn something about the experience you had as a result. In this project, you will be creating an on-campus laboratory. Okay, these spaces that we spend tons of time in every day. These spaces must have certain things, but we actually don't care whether you create this office space. This is the space I spent a lot of time in when I was an undergrad. If you go back here, you'll see this is actually the lab that's next to the new Linewiber building. Okay, and it's actually completely different now. So you can create my version of the lab, you can create the current version of the lab that's there, or you can create this lab right here, okay? The one that is around you when you're working on this course. You can choose, but you must have certain things no matter what. You must have a copier/printer. And I don't know if this room has one. It looks like it doesn't, but if it doesn't, you get to choose where it goes, all right? Things like whiteboards, stuff like that. We will begin in this first week or two with a kind of gray boxing process where we start off by kind of modeling out the different objects in the space, not at a ton of detail, and then we move in and start adding more detail, okay? We start adding things like windows, we start adding interactable objects, we start adding logic to the space. This is what I'm going to show you how to do today. We're going to add some logic. We're going to set up an affordance system and start adding logic to our actors, components to our actors, things like light switches, garbage cans, things like that, okay? In the final week or two of the project, we will start adding a lot of interactive elements, very interesting, kind of complex interactions. Okay, NPCs walking around with their own paths, characters who will look at you and who will talk to you if you click on them, stuff like that. Here's a really fun one. You can draw on the whiteboards. Implementing this task is one of the tougher ones. Actually figuring out how to allow the user to point at an object and actually draw and make little things on it. Here's an example of a custom task. At the very end of your project, you will get a choice of what final task you want to make. Here's an example of a very kind of very high achieving one. This is way more than you need to make. But we know we've got a film, an upcoming film. We're going to be watching The Matrix, right? Well, in that film, your day-to-day life is a simulation. And by taking a red pill, kind of identified, represented by that little red box on the left, you can see the Matrix. You can realize what it is and what surrounds you truly. And in this case, you go into a city and you can actually fly around the city. So not only do you gain a new environment, but you can actually gain the new ability to fly around and explore the city, which is really, really cool stuff. So what's the point of all this, right? What you're going to discover is that a lot of the current impactful applications for VR, they absolutely require interesting, interactive environments, okay? There's no way around it. We simply need to get you into Unreal, spending more time working on harder interactions with more logic, so that when you get to the end of the course and you decide what you want to make, you have a lot of options. You've got a lot of knowledge so that you don't feel too restricted. Okay? We got to get in there. We got to get a lot of Unreal Engine programming done. And we're going to do that. Things like this. Did I show you this tool, this app? This is an application, a game called Titanic VR. Very cool. You can take a field trip to the Titanic. And the Titanic, both as it currently exists, right, underwater, buried, you're in a submarine. You get to see it in its kind of decrepit, destroyed state. But you can also explore it back in time while it was still floating. And the Titanic has been recreated very accurately. And so you can have kind of very interesting educational, but also adventure game experience going through the Titanic. This one is Everest VR. This is one I'm going to show you later, but it's a VR experience in which you can climb Mount Everest without putting yourself at risk, without all the cost to get out there, to get flown out there. You can see a lot of realistic, very actually like literally footage, VR footage that was taken from people up at the top of Mount Everest. Very, very, very cool stuff. So this is the takeaway. Immersive interactive environments are really step number one for a lot of impactful applications in VR. You want to do a field trip, you want to do something educational, want to do a visualization, an exercise, okay? Something athletic, you got to have this knowledge. This project is going to get that to you, okay? All right, here are the dates that really matter. We've got today, we've got a week from now, a week after that, a week after that, and a week after that, okay? Or 5 days after that. You can break this project up into 3 disciplines. The first 2 are the most important, okay? Engineering, art, and production / kind of business, all right? Your first immediate concern is this P1 milestone. This P1 milestone environment, it is right here, okay, on the schedule. And after that, we're going to have a P1 alpha, and after that, a P1 gold. What exactly are these assignments and how do they work? Well, here's how they work. Let's go ahead and look at P1 milestone, this document right here. This document is going to explain everything you need to do, but there's one caveat. If you ever see it mentioning JIRA, then you don't have to do JIRA, okay? In this course, this semester, we've made the course a bit lighter for you. And I've been frustrated with JIRA lately, so JIRA is actually out. You don't have to worry about it anymore. You won't be graded on it. You just get those points. But what you're going to do is you are going to go into a task spreadsheet and find all of the P1 milestone tasks, and you're going to work on those this week. Okay? So you can see we're at our spreadsheet right here. And each of these rows is a task. Each row is a task. And there are quite a few rows as you go down here. We've got a section that's kind of preparing for the project. And there are quite a few tasks there. But we have a little section for the environment, okay? Right? You have a task where you want to block out the basic area of the laboratory, okay? So you're putting these blocks around. You're not worrying about materials or details or interactions. Just kind of getting the space set up, getting the scale right, stuff like that. We're getting some ceiling lights created and positioned. We're getting some windows chopped out of our walls, stuff like that. Get some computers in here, some garbage cans, all right? You're importing assets from Fab, you're importing assets from Sketchfab or other sources online. Okay, suddenly we hit these red tasks. What are those? Okay, they're clearly tasks, but they sound kind of hard, okay? We got that difficult whiteboard task, we got the copy machine task, but actually, look at this. The milestone is not P1 milestone, okay? It's P1 alpha. These red tasks are not due a week from now. They're due 2 weeks from now, okay? So don't worry about these red tasks. We're not going to be grading them in a week, all right? We're simply not. And you can look ahead and look and see what you're supposed to do, but you shouldn't do the red ones yet, okay? We then have an interactions. So up here we have a bunch of tasks that are about setting up the environment. getting objects in, but they're not interactive yet, okay? We're gonna eventually add a whiteboard actor next week, but this task is just about finding a good whiteboard object and kind of putting it in a reasonable place in the laboratory. But of course, then you have tasks that are about adding interactions. So for instance, here's the actual interactive whiteboard task. This is a tough one, okay? Actually programming the ability to draw on that whiteboard. If you look up here, we got some interactions you're going to have to do this week. We're going to do some of them today. So you're going to have to get navigation working. So you have to get teleport working so you kind of warp around. We need to build an interaction system, right? From kind of an architectural perspective, we need to get that important technology into our game. We need to build, this week, some lights that we can toggle on and off. We need to build an exit door that we can click on to end the game. We need to build an interaction where we can grab some pieces of trash around the library, because often students leave trash around the laboratory. I said library, I meant laboratory. You need to be able to grab those, pick them up, and then put them into the trash can. Where do you even begin? Well, the good news is that this project, and even project 2 as well, has a lot of hints and a lot of guidance, okay? Videos, things to kind of help get you in the right direction. It often won't do the entire task for you, but it'll really get you kind of rolling, all right? And again, we're going to do a lot of the work actually today in just a few moments. We're going to get into Unreal and start programming together. But you can see here that these deliverables, right? This P1 milestone, P1 alpha, you're just doing tasks with your teammate, and you are trying to learn more about how to program different things in Unreal. And that's that, okay? However, we have one final week, which is P1 Gold. And P1 Gold requires a custom object and a custom interaction. For most of the objects and most of the interactions, we specify in detail exactly what you need to do to get the points, okay? Exactly what you need to have. But in the final week, you will be tasked with creating your own custom object and your own custom interaction. These can be pretty much whatever you want, so long as they achieve kind of a baseline level of complexity. Well, what does that mean? That means you can have something as simple as a beer pong minigame, and that's it. Does not take long to do. Okay, let's take a look at what that means. Here it is. So in this, the player is testing the fire alarm, but there's this hidden room in the Beister building. Okay, we just went through a hidden room in the Beister building, and now we have this beer pong minigame. Okay, you can grab this ball and throw it, and if you miss, it'll reset. So there's some really cool logic there. We have a zombie outside our door, by the way. Yay! Okay, yay. If it lands in a cup, you get a point, and the cup despawns, and you get a nice cheer, okay? So you can see that, you know, this is some nice custom interactivity that we've programmed, and it doesn't need to be that much, all right? Yay! But you can go much further if you want to. You know, there's an example you can watch, an energy drink that alters your vision, right? The student created this one because they wanted people to know, like, CSE is tough, okay? This is a tough major. Spend a lot of time in these laboratories. Some of you already know that. Some of you are here at like 3 a.m. I know because sometimes I'm here at 3 a.m., all right? Usually trying to get the autograders working for the Game Engine Architecture course. But a red pill poster that reveals the player is secretly in the Matrix. A CSE Student Life Simulator minigame. This is one of the most deluxe minigames I've ever seen in this course. This team was a 494 team, so all the team members were already pretty jacked. Cracked from a game development perspective, okay? Kind of a scary, powerful team. Definitely OP. But let's go in. They got the SpongeBob characters. Here's our CSE Life Simulator minigame in this little room here. turn on the lights. Okay. Here we go. EECS simulator. 3, 2, 1. You've got these keys in front of you, and you have to like do your projects. You hit them to do your projects and get your auto graded score up. But you have to pick up this phone in order to keep your social life meter high, and you have to eat, I think, to stay healthy, or your vision will blur and you'll pass out.
So real.
Yeah, pretty much.
Hey, it's Jimmy. What? It's 3 a.m. in the morning? I know that. You're up, right? Yeah, anyway, I just saw this TikTok video that's like hilarious TikTok video, and I sent you the link. Yeah, go.
Look at this. We have particle effects that are spawning, right? When you hit the button, it's just beautiful.
Hey, it's Jimmy. Wanna study together?
Health condition is near death. Your social life is normie status. Everything's falling apart. Days left in the semester. 13, 12, 11, 10. Okay, so we're running out of time. Okay, GPA is 73. I don't know if that's any good. Health condition is near death. Your social life is engineer tier, which is very bad. So I think that's the worst possible, actually. Okay, anyway, you see, you are going to get a period of time where you are implementing standardized things. So we're trying to teach you some really useful techniques via the tasks that we provide and the hints we give you to complete them. In the last week, you're going to get the chance to build whatever you want. And I hope you will enjoy that opportunity to be a little bit creative, okay? Be a little bit artistic. If you have something that you want to say about your time as a CS major, that's going to be a good opportunity to do it. Good or bad, I don't really care at all. I hope you'll enjoy it, okay? But anyway, so that's what this is going to be. One big caveat here is that none of these tasks need to be perfect or bug-free or complete until the end of that P1 Gold. Okay? You'll get full points for any of these tasks so long as you have a non-trivial implementation of the task. Right? So you don't need perfection yet. You got lots of time, and in that final week, you're going to have time to fix things up, polish things up, get all the points. All right? At the very end here, you'll have a little bit of kind of production-related stuff. You'll have a post-mortem essay you're going to write. Essay, very scary, okay? Engineering, we don't do essays, right? No, this is the kind of essay the students actually like, if you can believe it or not. Because in this course, we don't care about your grammar, we don't care about your structure. All we care about is that you dump your brain. You rant and rave, okay? Anything that's on your mind as you think back about the project. That's it. 30 minutes, you're done, okay? Easy points. And a lot of students really like being able to kind of reflect on what happened, what they can do better next time. What was really annoying about Unreal Engine crashing all the time, right? So, okay, and I really enjoy reading those essays as well. So I can get a kind of a look into your experience and how things are going. Okay, so some miscellaneous info on Project 1. This is teams of 2, okay? Pretty small teams. Something to note is that your final project will probably be teams of 3 to 4. This is a really good chance to kind of meet people in the course and kind of get a feel for people you might want to work with and people you might not want to work with on that important final project. This is Unreal Engine. You are going to have a deliverable basically every week, and it's going to be kind of intermediate. The amount of points in these assignments is also going to go up as we go on. P1 Alpha will be worth more than P1 Milestone. P1 Gold will be worth the most. So if you mess up this first week, I wouldn't worry too much about it, but we do want to get you rocking and rolling by the end of P1 Alpha and P1 Gold. You are going to demonstrate your progress by recording videos. Same exact thing you've been doing on tutorial assignments and the exploration assignments. And for the final gold deliverable, you will submit source code and you will have a portfolio website. If you haven't created a portfolio website, this is going to be the course you do it in. Super useful thing for interviewing, and so we're going to make sure you have that by the end of this project, okay? Any questions about Project 1? Again, if there's anything referencing Jira in here, is there anything? I'm kind of curious. Any Jira? What about in here? Jira, no? Okay, good, sweet. You are not using Jira this semester. If you want something to track your tasks and your progress with your teammate, I would recommend using something very lightweight like Trello. All right, if you've used that before, you know what I'm talking about. Otherwise, just Google it, it's really good stuff. Okay, so today what I want to do is I want to move on. I want to talk about a pretty fun topic. I want to talk about the affordance interaction design pattern. One of the most important architectural ideas in game design and game development. In fact, the EECS 298 students, they are really cool 3D platformer projects. They use the affordance design architecture or affordance design pattern, and they use it to great effect. Have you ever played a video game where you can just kind of walk up to characters or walk up to an interesting object and a little button prompt appears, and you kind of press the button and you interact with the thing? Maybe the interaction is talking to a character, or maybe the interaction is the camera moves to give you a closer look, or maybe the interaction causes the character to push the object, like you're solving a puzzle. There's an idea that we want to be able to give affordances, interactions, you can think of them as, to different objects in an environment. And we want to make it very easy for the player to interact with these things, to trigger those affordances, trigger those interactions. And we want to make it very easy for us to create new types of interactions that we can then plop on to any actor, any object we want. And that's what we're going to set up today and kind of use a bit today, all right? Let's talk about virtual reality interaction systems. When you are born, when you are a new organism, a new infant, right? Your repertoire of interactions is very limited, okay? You can express very little, actually. You have the ability, it's a very famous one, to cry. That is it, okay? The cry interaction technique is very low tier, okay? Only noobs, only level 1 players use this one, okay? Why? Well, this interaction is actually quite crappy, okay? It's kind of, it's actually very, very crappy. It imparts almost no information. It is not directional, okay? You can't aim your cry at anything. You can't express different ideas with the cry. You can only express one idea. What's the one idea you express with a cry? Baby. What does the baby do? Express.
Literally anything. It could be like you poop your pants, it could be you're upset, it could
Yeah.
be you're mad.
Pretty much, right? The only thing the cry is capable of expressing is pay attention to me right now. I can't tell you why or what I need. I just can tell you over here, right? That's all you can say. It really stinks. It's terrible, okay? Now, as a child, as a human infant evolves and levels up, okay, they unlock a new technique for gesturing, right? They interact the ability to attract attention, but directionally, okay? I can now point or grab towards something, and this imparts a lot more information to human beings that may be nearby, okay? The system gets a lot more information when the infant is using this technique, right? You point at something. Eventually, the human being develops the ability to talk. And at that point, as that evolves, they reach kind of peak human expressiveness. They can really express very advanced ideas, very targeted ideas, and they can do so fairly efficiently, right? We go from, I want something, to, I want that thing, much more expressive, to, like, never shutting up, okay? and stuff like that. So we are built for interacting, especially with each other. Human-human interactions are just very, very common, and we're extremely good at it. Well, I don't know about computer scientists in general, but humans in general are very good at this. And you can tell here, it's not just about gesturing or talking. We are literally built to be able to read very minute, subtle movements and positioning of a human's face to tell what they are thinking and how they are feeling. You can express all you need to just by tweaking your cheek a little bit or shriveling your nose. It's very impressive. Okay? Sense of not only like your facial expressions, but of touch, okay? Can express a lot of emotion as well. Facial expressions, right, as we already talked about, and also posture is a very, very big thing, okay? If I walk up to someone and it's like, oh man, hey, like, how's it going? Like, it's super good to see, right? Like, this exact posture I have right now, none of the, home viewers can see it. That's why you gotta come to lecture. Like, this is a very open posture, right? Like, we're friends, probably, okay? I want to chat. It's a very good move, right? If, I come up something else like, and I get right in your face. That's a hugely, I'm very square to you. I'm kind of caving over you, right? I'm not trying to scare you. Thank you for taking my acting. Extraordinarily different, and nothing needs to be said, okay? And so, this human-human interaction, right, this human-human expressiveness is really impressive, and it has done well for humanity, for most of our existence, because most of our existence hasn't involved computers. Okay? Humans are boring. We all know this. We're computer scientists. We care about not human-human interactions, but human-computer interactions. It is so cool and fun and impactful and future kind of looking, future forward, that we have basically the entire School of Information that is all about human-computer interactions. Of course, we care about them too. If you're doing things in XR, you need to care about this stuff, or robotics. Okay? And so we have lots of attempts at human-computer interaction, lots of them quite funny. I like this one in particular at the bottom here. Very expressive this Roomba is right now, holding that knife. Be very careful. And we have some interesting ways of interacting with computers. This is one of our earliest ways to interact with computers, through the terminal, the command prompt, the command line. Does anyone remember the first time they saw one of these things? I grew up as a Windows kid, and so I didn't interact seriously with a terminal like this until EECS 280, my first course at the University of Michigan. And I'm learning about like LS, like what on earth is LS? What are these things? Right on, what's the dot mean? Okay, 741 dir, what is this, right? It's crazy. It takes a long time to get used to this kind of method of interacting with software and computers, but it is very fast, it's very precise, and it can be a kind of good programmatic standard as well, if you want software to talk to other software. But it requires a very specialized, trained, educated human, which means it's not very good for mass deployment, okay? An interesting one that has kind of become a bigger thing of late, it's clearly getting a lot better. How many of you have ever done like the chat, like the voice chat mode with ChatGPT? Anyone? No? It's surprisingly good at understanding you and interacting. But before that even, we had things like Alexa, where you would basically just be walking around your house. You could be doing other things, and you could just say, "Hey, Alexa, set a timer for 5 minutes while I'm cooking something." Right? Fairly fast, but kind of clumsy. Sometimes they misunderstand you. Sometimes they don't hear you. They do the wrong thing. But it is very accessible. Humans already know how to talk to other humans, so talking like a human to a robot is a very nice thing. You don't need much education to make that work. How many of you remember motion tracking? Okay, it was all the rage in a few generations ago in the world of games. The Wii, does anyone remember the Nintendo Wii? Okay, with their motion controller. Sony had their PlayStation Move, which was kind of an ill-fated attempt to replicate the Wii motion controller. And then Microsoft had a really interesting take, which was the Xbox Kinect, which is now, I think, the Azure Kinect. And basically what it would do is it had a camera on it, a device, and they would kind of track your body and kind of estimate the positions of bones, a rig. All the 298 students are like, hey, I kind of get what they're doing. And basically, if we know the skeletal structure of the player and how it's moving around, we can map that. We can target a mesh onto that armature as it moves around, and we can have a character that kind of follows the motions of the player. Does anyone remember the Sony iToy? Anyone ever heard of the iToy? No? Oh, okay. Anyway, it's very, very fun stuff. There's a lot of very interesting video game hardware history that I got to live through that unfortunately all of y'all will have to enjoy just from a historical perspective. But anyway, this kind of thing is very accessible, ultra clumsy. The big problem with the Kinect is that you can see right here in the footage, it's laggy, right? It had about a half-second worth of lag, which made a lot of fast-paced, action-oriented games and apps just not viable. It also very commonly, routinely misinterpreted your movements. Famously, this game, Sonic Free Riders, was a completely non-functional piece of garbage. That was very difficult to get it working with the Kinect, and yet Sega sold it like full price to a lot of people, okay? Yeah, Sonic is a little bit of a meme these days for many reasons. One of the reasons is that Sega just puts out garbage with his name on it. And be very careful with your brand when you're doing that kind of thing. Very low reviews on that one. One of the most interesting, I guess, most dominant forms of human-computer interaction these days, I kid you not, is simple game controllers, okay? You will see the Xbox controller, no joke, in the hands of medical professionals controlling robots, in the hands of defense professionals controlling drones. It is very strange to see such a source of joy being used in such serious situations. But it is used there for a reason, right? Humans have become very good, generally, at using devices like this. But it does still require a specialized human. There are a lot of people, especially older generations, who cannot use these devices, okay? For very good reasons. You don't realize just how many darn buttons are on these things until you start counting. This controller alone probably has about 20 different inputs you can signal to the software, okay? Very crazy. So, right, we really would like a hybrid approach, right? We like this controller, but what if we could make it easier to use? It is very efficient, but what if we gave it fewer buttons? What if we gave it some motion controller gesture-based stuff? Okay? Humans, even children, know how to point at something. Even dogs understand what this means. Okay? A lot of them do. And so, can we combine the efficiency and expressiveness of a modern video game controller with the naturalness and accessibility of the human gesture, the human finger point? And the answer is absolutely. Okay? And that is what we're going to do. This, what you're seeing right here, is going to be our selection system. And it's going to be a system where we point at an interactable object. And you can't see it here, but today we're going to do it. When you point at an object, an actor, that has an affordance on it, it is going to change the color of our cursor so that the player knows they can now pull the trigger and activate whatever interactions, whatever affordances are on the object. Okay? And so that's how it's going to be. That's what we're going to do right now, actually after our break. But development phase one is going to be the selection system. And we're going to start by using something, a technique that you already know, the line trace. If you're a Unity developer or a Godot developer, you know this as the raycast. Basically, we're going to shoot a line through thin air, and we're going to see what we hit. Okay, and that line is literally the line you're seeing right here. What we're going to do is we're going to have this piece of data, very important piece of data. It's going to be called the current hovered actor variable. It's called the hovered actor because we kind of call the act of pointing at something hovering them. We're kind of hovering our line on them. We haven't pulled the trigger yet, but we're considering pulling the trigger on that item, that actor. So we're going to store whatever we're pointing at in that actor, that current hovered actor variable. You can see it's a variable of type actor. And, okay, when we detect that the player has pressed the trigger, we're going to print the name of that current hovered actor. Okay? And that is what we're going to do for this phase 1. Okay? This is called something different in Unreal Engine like 5+, like shoot left, trigger left. We're going to have to find something. They're always renaming what they call this. And so we're going to have to find it. Hopefully we can. But that's what we're going to do for this first step of our development process. And then we're going to do some really interesting stuff just afterward. So what I want to do is I want to take our 5-minute break, and I'm going to get Unreal ready to go. I'm going to get the headset ready to go. I should have wore contacts today because I'm going to have to get my big chunky glasses into this headset. We'll see if we can do it. Everyone, see you in 5 minutes. I'm going to turn the music on, and we'll see you in 5. Let's go. Okay. How do you work for extended periods without a headache?
Yeah.
Does the headache come from dizziness or nausea or just the forehead?
Just the question.
I think I used to run like 14 miles at cross country practices like every day. Like the amount of misery that I have been exposed to has been very useful in like not caring at all about this. You definitely get used to it, and I think you even get used to things like the nausea too. And I'll talk about that just in a little bit because I think it's an important topic. One of the things that is blocking and suppressing VR adoption today is still the discomfort of having a face hugger attached to your face, right? There is kind of like a very deep human discomfort with having something on your face for long periods of time. I remember the first time I wore glasses, I thought it was just very annoying up here, but you do get used to it. And so I think it's gonna be something that you also get used to. It's also, and I'll start speaking to everyone because I think we're about done with our break. How many of you kind of feel discomfort when you put the headset on and then as time goes on, it's not super comforting, right? That's definitely a thing, right? And it's gotten wildly better. But, right, those glasses, the glasses are the target for VR these days, for AR as well, because we know, we have very good proof that if we can miniaturize VR, get it to this point of lightness, get it to this fashionability, then that will be enough. Pair it with a killer app, like the ability to see, and people will adopt it en masse then. But how do you deal with discomfort for wearing headsets for a long period of time? Over time, you will develop resistance to it. It won't be a big deal at all. You won't realize you have the headset on. Again, my advice for development is this. You really want to get to a point where you can quickly put the headset on and develop, and off with a quick flick of the wrists, okay? And so work on getting the headset tightened just right to allow you to do that and move between development on the PC and testing on the device. If you find yourself getting motion sick, you will develop a resistance to this as well, and it won't feel nearly as bad over time. This actually reminds me a lot of when I was going up for my initial flight lessons, kind of flying around Ann Arbor. I got very sick. I remember my first flight lesson, I was only in the air, I think, for about an hour flying around. And when I got home, I was sweating bullets. And I was exhausted. I remember going home after my first real serious flight lesson and immediately like falling into bed and falling asleep. Okay, it was that mentally exhausting. Physically, I was motion sick. It was just the works. These days, when I go up, it's like, it's all right. Like, you don't really feel it. You don't really care anymore, right? And you will develop a resistance to this too. My advice is try not to be in the VR headset for too long. Try and pace yourself. Do an hour of development, but then put it away and do something else for a bit, right? Don't go too long. And as you get more sleep, as you get more exposure to all of this, your resistance will build up pretty quickly, okay? And then it will feel like home. It is very fun to develop this way, at least for me now. Okay, everyone, let's go ahead and rock and roll. You know the mission. We got to get a line trace going. We need to detect when that trigger is getting pressed. And so we need to figure out where are we going to put this logic. Well, we need to write some logic, and we need to decide where it's going to go. And one of the hardest things about Unreal Engine, if you're coming from Unity or another game engine, is that in Unreal Engine, your logic can be put in many different places. You can have logic on the game mode, you can have logic on the actor itself, or you can have logic within a component that is on the actor, like right here. You can have logic and blueprint code be in many different locations at once. So you often have to kind of search high and low for it. In Unity, it's much easier. It's all going to be in a component. In Unreal Engine, it might be in a component, or it might be on the blueprint itself directly, or it might be in a game mode class that is running over here, kind of in the background. You know, you just never know. So what I want to do is I know that when the player spawns in, we spawn in as something called the VR pawn. The VR pawn is an actor that has been configured to spawn in when the player spawns in. And I know this, how? Because I can go to Window and go to World Settings. This provides a really cool World Settings panel which shows us a bunch of kind of, interesting stuff. Oops, Unreal Engine has frozen. Shout out to Unreal. Oh my gosh. I was just scrolling through the menu. What's the problem here, right? Okay, you do wonder, like, exactly what, like, where was the function, where was the program counter at? What instructions were we just running there? What tripped us up, actually? It was probably like trying to cache something in the background, load some materials or something. I don't know. But we can go to World Settings and see that there's this game mode called VR Game Mode. And if we go to VR Game Mode, it is a blueprint that has a bunch of little variables in it. All of these are variables, believe it or not. And one of those variables is called the default pawn class. VR pawn right there. If I click on this, it brings up the VR pawn, which is in our content folder. It's in the blueprints folder, and here it is. It is a blueprint. I can double click it, and now we are looking at a blueprint. This is the event graph of the blueprint. This is where the code is, but I can look at the viewport of the blueprint as well, and I can see what the blueprint looks like visually. Now, Unreal has frozen again. Amazing, right? These are good machines. Like this is, we got some good processors and some very good GPUs in these machines. Maybe the hard drive is a little bit slow. Maybe that's what's causing it. I don't know. I have no idea what this thing is right here. What on earth is that? Never seen that before. But you can see here that our VR pawn, we can see a little VR headset in here and the camera's in here. If we look, we can also see the hands are in here as well. The hands are actually, let's see here. Here it is. Okay. Oh, where are you? Hello. Oh, well, never mind. I guess, can I move this? Yeah, there it is. Okay. So I can kind of sort of move that hand out there to get a better look at it. But this VR pawn blueprint is the blueprint that is going to control our, it's going to give us features as a character. We can see here is the logic that does our teleportation. Here's the logic for our snap turning, where we turn right and left using the joystick. There's some other stuff, right? Blah, 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 tracking, I don't really care about that. Here, input, grabbing with the left hand. Okay, releasing. But what we really want here is we want a trigger. We want to know when we have pressed the trigger. And so what I want is I think I want an input called shoot. Okay, shoot left or shoot right. I forget which one we usually use. Which one do we use to teleport? The left one, I think? Yeah, I think we use the left. Is it right? Oh, okay, hold on a second. We gotta make sure of this, okay? Yeah, this is like the one thing you don't want to mess up. All right, so let's get in here. And oh yeah, you're right, it's the right one. So we're actually gonna use the left. Let's use the left hand to control our pointing, okay, and our interactions. I think actually you could use right or left. I don't think it matters that much, but I think I'm going to use left. So let's go shoot left. Bingo, right there. This is an input, and we want to test this right away. So we're going to print a message, shoot left, and we're going to compile up here, and then Control-Shift-S, and let's press that left trigger. And I can't really see, so you got to tell me if you see any blue messages showing up. You see them? Blue message? Good. And if I click in, I get one message. If I release, I get no message. And if I hold it, I don't get any more messages. So this is exactly like to a T what we want. That's extremely good news for us. But now we need more logic. what do we want to do? We want to ray cast. Sorry, we want to line trace. Okay, I'm getting my engine terminology mixed up. We want to line trace out into space, 3D space, and we want to see what we can hit. And so this is an operation. It's a function called line trace by channel. And, you know, by itself, it's not going to do anything. We need to actually have some event that's plugging into this. This is the kind of thing that we want to do every frame of our game, every tick of our game. So we need some sort of event, not an input event like one of these. Do you know what the event is called? It's a life cycle function. It's an event. It's the analog of Unity's update. Yes?
Event tick.
Bingo, it's event tick. Good job. So I can right click and then search for that event tick and boom, it's right there. If I search for update, what do I get? Oh, this is Unreal should know that like in Unreal Engine context, tick is a synonym for update. So it should show up, right? At least at the bottom of the list. What a brutal thing. I'm very surprised they don't notice that and fix that. That really gets a lot of beginners. Okay. If they want to steal users from Unity, like, you got to know what Unity users are going to be looking for, right? Anyway, all right, so this is a line trace, and it's a function. It's a complex function. Look at all of these inputs, all these parameters we can provide. Well, the first thing I want to do is I want to make sure the line trace is going to be visible. So I go to draw debug type, and I'm going to go for one frame. And I can look in this other stuff. I don't really care about this other stuff all that much. We can change the color, which is pretty cool. But this is the most important part up here, right? Where is that line going to start in 3D space? XYZ, where is it going to start? In XYZ, where is it going to end, okay? This XYZ is a data type called vector3. And that's going to be important because we need to make a vector3. We need to make a vector3 and figure out what we're pointing at. But this is going to be a lot of code. So you know what? I don't want to do this. You know what I want to do? What happens when you have a lot of code and it's kind of messy and you want to like bundle it up? You want to bundle it up into a really useful thing in programming that we call a... It's not a class. It's a way to reuse code. It starts with an F. You learned it in 280. Say it.
Function.
It's called a function, okay? It's called a function. So let's do this. I'm going to pull my execution out of here, and I'm going to start just typing. I'm going to start typing. Let's call this function determine. Actually, no, that's not how I'm going to create a function. Let's. Is there a function in here? Cast to function. No, I can't do it that easily. Let's go up to function, and I see this big plus button. I'm going to call this determine hovered actor. That's a pretty nice name for a function, very self-explanatory. Our function is going to take no parameters. And I've created this function, I've compiled the function. The function doesn't do anything, it's an empty function, but I can still go to my event graph right back here and watch this. I'm going to just start typing determine and boom, suddenly I have this beautiful function right here that I can call, and it looks very nice, doesn't it? Very nice and clean. We're not going to have a bunch of nodes here messing with everything. I double click that node and I go into it. Okay, you can create your own nodes just like you can create your own functions. So I'm going to come in here. What on earth is that thing? I have no idea. I'm going to bring this out here. I'm going to get that line trace by channel, and we need some information. I want to line trace starting at where my left hand is. But how can I get this information? Well, if we go over to the viewport here, why is it gone? Why can't I click it? What on earth? Unreal 5.6 is cursed. What on earth is going on here? Let's get out of here. I'm spooked by that. Let's open up the VR pawn again. Maybe the UI will fix itself. Where's what? Where's the viewport? It's dead. It's gone. Rest in peace. Maybe it will open up automatically if I double click over here. Guess not. I hope your viewport doesn't just run away. like mine did. Can I get a view? Viewport window? Can I bring it back? Is there a viewport in here? Hello? Palette, find, components. Oh my goodness. Yeah, Unreal is just a cluster, isn't it? Oh well, all right. Well, we don't need the viewport. I'm going to tell you what's going on. Remember that left hand that I showed you a few moments ago in the viewport? Well, actually, it's a component. It is a component that we can see over here. It is the, let me see. It is the, where is it? Motion controller right grip, left anim, right grip, left grip. Here we are. Open it up. Here's that hand left component. I can drag it out here. And I can actually plug it in right here. And actually, you know what? No, I have to grab the location. Let's do this. Get location. I want the world location. The actual 3D location within the world itself. And see how it's yellow? It's a perfect Vector 3 fit for that start. Okay? I'm going to set the draw debug type to 1 frame, so hopefully we'll see it. Compile, and we want to test our game. In general, you always want to write a tiny bit of code and then test, and then a tiny bit more code and test. Why do you do this? Well, it's a part of that iterative design process. If you have a bug or something happens that you don't expect, if you've only written a tiny bit of code, you know exactly who the guilty parties are. So you can look at those lines of code, it's easy to fix. If you write 100 lines of code and then you test and something is wrong, you've got 100 lines of code that could be the guilty party, okay? So much harder to debug if you write too much code between tests. So you should be testing all the time. And you want to make testing as fast as possible. So look at this, Can you see it? My left hand right here has this debug draw right here. This line, it is going from my hand to that kind of center location. This is 0, 0, 0 down here. It's the center of our scene, of our map, of our world. And so it makes sense that it would go there. But this isn't actually what we want, is it? This actually isn't quite what we want. And so, what should we do? What should we do? We can do some 3D math. That's what we're going to do. We'll do some 3D math because we need to calculate an endpoint that is out in the direction of our hand. And so, how can we get that? How can we get that? We need to calculate this point by taking the world direction of our left hand and adding it to the direction that our hand is pointing in. This is 3D math. It's just a little bit weird. Imagine if our hand is kind of pointing in this direction. This game object, this actor, is going to have a few special vectors, a few special directional vectors that are going to give us the direction coming out, up out of the hand, out of the forward of the hand, or out of the right of the hand. And as our hand rotates, these vectors will also rotate, which makes them very useful for getting that hand pointing direction that we want. In any case, let's go ahead and we're going to grab this hand again, but we're not going to get the world location. We're going to go for the, let's go for the forward. Get forward vector. This might not be what we want, but we have to test it, okay? So here's what we're going to do. We're going to take the position of our hand. We're going to add the direction of our vector. We're going to multiply a little bit, actually. Let's multiply it by, I want to multiply this by like a number, okay? Let's make literal float. There we go, right up there. And we're going to multiply, I'll plug this vector in. It's a little bit messy, isn't it? I don't like doing math and blueprints. Okay, multiply it by 100, how about that? And then we will add these two things. So let's add these two vectors, and here we go. I'll explain the math one more time in just a second if it works. Let's go in here, Control-Shift-S, compile, Control-Shift-S, let's try it. We are taking the actual world position of our hand in the scene, and we are saying we want to add a little bit more in the direction that we're pointing. to hopefully get a line trace, an endpoint that is kind of coming out here in front of our hand as we look around. So we're going to find out if that worked. We might need to use the right vector or the up vector, depending on how this hand model was set up. I wish I had the viewport working, because then I'd actually be able to look at it and I'd be able to probably tell. Look at this! Oh my goodness, look at this. Look at that. It's coming out of the bottom of my wrist. What on earth? Isn't that funny? Okay, that is not what we want. And so, instead of using the forward vector, what are we going to use? Let's try the up vector. Doesn't sound like it, you wouldn't think it would work, but we'll see. We will see. So I'm going to put my hand out here, and we're going to find out which direction this is. Oh my goodness, look at that. Okay, it's coming out of the back of my hand. All right. So we got one coming like down, and we got one coming out of the back. Let's see if the right vector works. Here we go. Okay, and let's see here. Oh my goodness, it's perfect. Look at that. The right vector is the one that's coming out of my hand. Imagine that, right? Coming forward out of my hand. Well, there you go. Okay, whatever you got to do. So we now have this vector that's kind of coming out of our hand. You might say, well, is it going out far enough? You can extend this out by multiplying this number a bit further. So you might say something like 500. Maybe you want to make sure that we're going to be able to point a long way out. In any case, once that line trace hits something, we need to know what did we hit. That's the entire point of selection. So if you see here, the line trace function, this node has many inputs, but it also has an output. And importantly, this output is called a hit data structure. This is a data structure that contains a lot of information about what we hit. And what we can do, first of all, this might be null, I think. And I think this is actually a Boolean. Yeah, if we hit something, it returns true. Otherwise, it's false. And so what we can actually do is we can do an if statement, a branch. And so if we hit something, we can take this output, this hit, and we can break that hit result. We can break it open. Notice how like this blue line is now going through my branch. It's so messy. I can double click this line and I can just kind of pin it up here to make it a little bit more readable. And I'm going to break that hit and look at all this good stuff, all this information about what I hit. The most important one is probably this hit actor. This is going to tell us, what did we hit? Okay, what did we hit? And so what I want to do is I want to take this hit actor and remember our mission. Our mission is to put this into a variable. So let's create a variable. We need a variable. What was it going to be called? It was going to be called current hovered actor. And it's not a Boolean variable. It's got to be an actor variable, because it has to hold that actor that we have hit. So here's the actor data type. I want an object reference. And so here we go. We now have that variable. And I can do this. I can drag this hit actor out here, and I can go set, and I can go current hovered actor. I think I can do that. No. Can I do that? No, I can't. Let's right click, and let's search for current hovered actor. There it is. I got a get function. I got a set function. I want to set it. So let's bring this over here. Let's set that value. Pin it up here. I'm just going to plug that actor in just like that. One more thing I want to do is I want to, if we didn't hit anything, then I want to set the current hovered actor. I want to set current hovered actor to null. Like, can I make a null here? Can I make a null here? I think I can somehow, or a none. Get description for none, platform ID. I think I can just leave this. I don't think I need to fill this, and then it's going to be none by default. Okay, sweet, good. So, right, this logic, right, I don't like using blueprints and visual programming that much because I'm pretty good at textual programming. I can do it very quickly. So I don't enjoy the beginner benefits of it. And yet, to express basic logic, it takes a lot of nodes, it takes a lot of wires. It's very verbose, okay? But it works, and it can be quite fun to use. It's just not very fast. So this is what we need to test. We've wrote a lot of code here, and what I want to do is when I press that trigger, I want to not just print this message, I want to print the name of my current hovered actor, okay? So let's do it. I'm going to print the display name here. I just have to bring that variable out and just print it right here. If it is null, this will cause an error, but I don't really care that much. So let's go ahead and do it. Let's test it out. So we're getting in here. We got that nice function. I'm not sure what this cube name is called. What is it printing, y'all? Cube, that sounds about right. Well, let's go over here to the sphere. If it prints cube on this one, we're in big trouble. Let's do it. What is it printing?
SM01.
Bingo. All right, everyone, mission complete. Things are working. Rock and roll. Good stuff. We have our selection finished, kind of. There's one more thing that I want to do about this selection, but actually we're going to do it in just a moment. Because here's now our next big problem. We have finished our selection system in that now we can point at things and the user can, print its name. Our code has access and knowledge of what the user is pointing at, and it has knowledge of whether the user wants to execute that thing, okay? But what does it mean to execute a thing? When a player points at something and clicks, what does it mean? What do we do? It actually depends on which object we point at, right? And so we really need a way to customize what happens to this object in particular when you point at it and you click on it. And it's going to be different for every object. Well, the way that you tend to do this, the nice, scalable, efficient, and accessible way to do this is called an affordance system. We sometimes call it an interaction system because an affordance is kind of a word, it's kind of a rare word. An affordance, if you look it up, is some sort of a use or purpose or functionality that a thing might have. Okay? So on The Sims, this slide object might have a slide affordance, but it also might have a watch and observe affordance. So the other Sims can kind of watch people have fun, and that's also kind of fun. This stereo might have a listen affordance. But that same listen affordance might also be on the TV, okay? Or on other Sims, because you can listen to other Sims as they talk and stuff like that, and engage with them, right? One of my jobs on The Sims was to build a waiting line affordance, where if you went to an object and interacted with it, you might put an affordance onto that object that would cause a waiting line to form. And once you got to the front of the line, you could execute the other affordances on that game object. Okay? In my game, Greek Tragedy, we use a lot of affordances. We have a lot of objects in the environment, like notes and cups and doors, documents. If you look at this notepad right here, you'll see it has a component called affordance F document. And that affordance allows you to walk up to something. Any affordance allows you to walk up to something and click with it. But this particular affordance will show you a document when you click. There are other objects that do different things when you click. This one has a collect affordance that will take this apple and it will put it into your inventory so you can eat it later. Okay? This door right here has an affordance for traveling. So you can interact with this door just like you can interact with the apple and the note. But this one will actually transport you to a new location. So you see, we have all these affordances, but they derive from a base parent affordance class, and they all have an interact function that they override to do different things. And that's what we're going to do, okay? We're going to program things like an exit door that prints a goodbye message and then quits the game. That's going to be two different affordances that we're going to run. So let's go in there and get into it. Here's what we're going to do. We want to have an affordance base class. We're going to use a technique called polymorphism. I'm going to create a folder called, let's call this affordances. Inside this folder, I'm going to create a base affordance class. I right-click, I go to, let's go to, let's see here. I don't want this to be an actor. I want this to be an actor component so that it's a component we can put onto actors. Let's click on it. I'm going to call this capital A affordance. Oh, no, not like that. What? Okay, rename. Okay. And a reminder, all of this is recorded, so you don't need to be paying perfect attention and following this to a T. But we're going to create this affordance base class. And it's going to have nothing in it except for one thing, a function called interact. That's it. We're done. And in fact, we're not even going to put anything into this interact function. Okay? Now we are done with the affordance base class. The only reason it exists is to use polymorphism, which we'll talk about very soon, to basically make sure all the child classes of affordance are guaranteed to have a nice interact function that we can call. So I'm going to create another blueprint class, and I'm going to say I want an affordance that prints a message. Okay? We're going to create we're going to make this a child of the affordance base class. So I can search down here in all classes. Yes, pick the parent class. I want the parent class to be the affordance class. Here it is. I'm going to call this AF. Let's do message. I name it AF so that when we just see the name, we already know it's an affordance, i.e., it has an interact function, guaranteed. Okay? I click on it, and what I'm going to do, I don't care about event begin play. I don't care about event tick. The only thing I want to do is I want to override that interact function that I inherited, look up here in the top right corner, from my affordance base class. I'm going to go to interact. I'm going to open it up. Look at this. It's going to call the parent version of affordance, but I actually don't care about that. You can leave it in if you want to. It's not a big deal. But here's what I want to do. I want to print a message. I want to print a string. Here's a question. Which message should we print? Which string should we print? We could print any string, right? But here's an idea. Let's let our user of this affordance component, let's let them decide what message they want to print, okay? Here's how we're going to do it. If you're not used to game engines, this is very unusual, very strange. But I'm going to create a variable. Okay, I'm going to call this message to print. It's going to be of type, let's see, string, hello, string, there it is, string. And importantly, you see this eyeball right here? I'm going to click it to make it public and editable. And I can just bring it in here. This variable is the message that we will print when you interact with this affordance. I'm going to compile it. When I go back to my Unreal Engine editor, do you see this cube right here? You see this cube? What I can do is I can add a component and I can search AF message. Look, it just shows up, AF message, just like that. When I add it, suddenly I can see my variable. I click on my component, AF message, and my variable message to print is there. It's so nice and easy. I don't have to edit the code at all to change the message that I'm going to print. And I'm going to print this message, hello affordances, okay? And you know what? I can add a second one if I want to. Why not? I can add as many components on here as I want. And this one is going to be almost time to go home. Not for me, I've got another course I have to teach tonight, but for you, hopefully you can go home soon. So when I interact with this cube, I want to run this interact function, and I want to run this interact function, okay? How can we do this? If I run the game right now, and I click on that cube, nothing's going to happen. I have to actually grab these components on this actor, and I have to call those interact functions that they have. Otherwise, nothing's going to happen. So let's go back into our code here, right? Let's go into the VR pawn right up here, compile it. Whenever you see the compile button, just go ahead and compile. And I want a new function. Currently, when I click that left trigger, we're printing the name of our current hovered actor. But I want a new function that's going to do something really nice and useful. I'm going to call this function. Always name your functions well. It's very nice for the future. Okay, execute affordances on hovered actor. I love long variable and function names because it just makes things so obvious. But I know people don't like to type that much. Okay, when I call this function, what I'm going to do is I want to take that current hovered actor, just grab the current hovered actor, and I want to check if it is null. So is valid, okay? I'm going to branch on that. So if we have a current hovered actor, it's not null. If we have a current hovered actor, I want to take that current hovered actor, I'm going to just drag it out again here, and I want to get components, okay? Get components by class. I want to grab all the components of a certain class, okay? When you look at this cube, it has one component, a static mesh component, and two AF message components. Do I want to grab all three of these? No, I only want to grab two. I want to grab these two because they are affordances. Okay, they are AF message affordances, but what if we have different types of affordances? Well, I want to grab all the affordances, not just AF message affordances. So here's what I'm going to do. I'm going to grab all components on this actor of type affordance, that base parent class. That's the reason we have that parent class. This is what polymorphism is. We can reference and grab all of the affordances we want, no matter what they are, no matter what kind of affordance. And we can grab them all by using this base parent class. And using them, we can do a for each loop, we can iterate through all of them, and we can call that interact function on all of them. Isn't that amazing? This is the magic of polymorphism. If you don't appreciate it right now, you will when you spend a bit more time with it. But this allows us to go through any affordance that is on this actor. And we know that because it is an affordance, we know it has an interact function, which means we can call it in this loop right here, right now. Okay? So let's do it. Okay? This function is almost complete. The last thing we need to do is we actually need to, call it. Okay? When we press that left trigger, let's call that execute. What's the function called again? What did we call it? Execute affordances. Here we go. Here's the function. I just drag it right out. Boom, just like that. Control-Shift-S. Remember, not Control-S, Control-Shift-S. Compile, Control-Shift-S again for paranoia. And now I want you to be looking for those messages. What do you expect to happen when I pull the trigger once on this cube? I think it's that cube right there. Ready? I'm going to point at it. Ready? What do you expect? 3, 2, 1, click. What did we get? Click. Okay, what did we get? All right, we got both of those messages, didn't we? Rock and roll. Very good. Mission complete. We can put affordances onto any object that we want, any actor that we want, and they just happen. But maybe we don't want to print a message. Maybe we want to exit the game. Okay, this is now our exit door. And we can't just print a message to exit the game. We need to actually have a new type of affordance. So I'm going to go to my content drawer. You see we have one affordance in the base class here, but we want another one. I'm going to create another blueprint class. And here's a little spoiler. Blueprints are literally classes. Everything you know from 280 and 281, that's a blueprint, okay? Blueprints are classes. Classes are blueprints. They got all the features you expect, okay? I'm going to, again, I'm going to inherit from that affordance base class. I'm going to call this one AF_QUIT, okay? AF_QUIT, and just like our other stuff, I don't need these things. I'm going to go into my function. I'm going to override that wonderful interact function, and I'm just going to run a quit node. That is it, okay? That's it. I'm done already, okay? The last thing I have to do is I have to go grab that AF_QUIT component, and I'm just going to slap it right on there. I could put a message component on with it, AF_message, but let's go ahead and see what happens. Okay, you see that door over there? If this is working, I just spent 2 seconds, and now we literally have an exit door working just like that, okay? Do you feel the magic? Do you get the point of this? Why we set this up? 2 seconds. If I wasn't talking to you, it would have been even shorter, okay? 2 seconds to make a new component, a new interaction just like that. Okay, well, how about a really fancy one? I want to finish this lecture up real quick let's do this. I'm going to create a little bit of darkness in here. You see how dark it is? Well, I want to have some lights on my ceiling. Let's go get some lights. How about a point light? Beautiful. Put it on the ceiling. Unreal Engine has incredible lighting. Okay, it always had. I'm going to have 2 lights in here. And what I want is I want to have a little light switch. Okay, a little tiny light switch like this. And I'm going to make it really nice and tiny. And I'm going to call this thing a light switch. Okay, I know I don't have a ton of time remaining. But I don't want to quit the game, so I'll get rid of that component. I need a actor. Let's call this, we're going to derive from affordance again, like we always do. And then I'm going to go AF toggle actors. Okay? This is an affordance that is basically going to allow us to turn a list of actors on or off, on or off. Let's go into our function and override the interact function, just like we always do. Now, we need to use this right here. Let's call this hidden, okay? Or set visible, I think. Let's do this. Let's create a variable. Let's call this actors to toggle. And I'm going to go to the actor data type. There we are. But I'm not going to go in object. Actually, I am going to do it in object reference. But over here on the right side, I don't want just a single variable. I want an array of things that I can alter. I'm going to make it editable right there. And so now we have this array of actors that we can actually mess with. We can go into a for each loop if we want to. And we can turn each of those actors. Let's go, I think it's hidden, is it? Set actor hidden in game. Boom, that's exactly what we want. So what we're going to do here is we're going to also keep a variable that says basically, let's call this on or should turn on. We'll keep this one hidden. We won't make it visible. And what we're going to do is we're going to use this variable to decide whether we should turn things on or not. Oh, we don't want it to be an array. We want it to be a single. Change variable type. Oh my gosh, it's going crazy. What's going on? We're barely even using it yet. Okay, get rid of that. I'll just delete the darn thing. Okay, oh, here you go. It looks like it's good. Okay, good. So now we have this interact function that's going to turn all the actors on or off. At the very beginning here, we need to flip this. So let's go ahead and set should turn on. We're going to set it to the not, the negation of the variable. So basically, once we turn it on, the next time we click, it's going to turn off. So I think that looks pretty good. Let's go ahead and compile this, and then we're going to go back and we'll add on this AF toggle actors. Boom, it's right there, super easy. Look at this, we have our own array of actors we can toggle. So I can add an index to that array, let's go ahead. I'm going to name this like, point light 1 and point light 2. So we already know the names. So let's go ahead and on this actor, I'm going to type in point light. There it is, number 1, and then point light 2. Let's add a second one. Point light 2. Good. These are the 2 actors I want to toggle on this light switch. Let's go and see what happens. I'm programming very fast here, so issues maybe. Let's see here. Okay, go over there. Click, 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 click. Oh my goodness, it was just that fast. What was that? Like just maybe 1 or 2 minutes? And I already have interactive lights and exit door. I've got everything I want. There's one final thing I want. Give me 1 more 60 seconds. When you point at a particular thing that you can interact with, we really want to change the color of our light switch. Okay? Let's go back into our VR pawn. In here, in our determine hovered actor, we have a little slot where we can change the color if we want to. So let's go ahead and I'm going to create one more variable. This is desired, let's go just laser color, I guess. I'm going to change the type to a color. And there we go, color right there. I'm going to plug this in right here, the trace color, boom, just like that. Now, if we hit something, if we don't hit something, I want to set this color here. So let's drag this out here, set the color. What do we want to set it to? Let's make color, and let's do a full red, okay? 100% red. However, if you do hit something, this actor right here, let's go ahead and get components by class. I want all the affordances that this object has, not like that. Okay, all the affordances this object has, let's get the length of this array. If it has an affordance and it's a larger than, I can't believe you need to type greater than. I can't believe they did that. If it's larger than 0, then we'll go ahead and branch and we will set the color, set laser color to make color. You're seeing how fast you can program in this when you're going. What color should we use? Blue maybe? Yeah, why not? Okay, lots of blue, we'll punch that in. And then the last thing is that this control flow won't get here, so we do need to drag this over here just like this. Let's give it a shot, okay? Compile, Control-Shift-S, run it. And let's see, I'm going to point up in the sky. It should turn what color? It should turn red, right? Red. There's nothing for us to click on. But when I hover on this object, there's nothing, right? Absolutely nothing. But when I hover on this exit door, it's blue, hinting to the player that they can click on something. When I move it to the ground, it's red. There's nothing on, there's no affordances on this actor. When I go to the light switch, I'm too far away. Oh, now I'm close enough. Boom, I can click on it. All right. And oh, it looks like maybe it's a little bit messed up. It's a little bit spooky, right? I'll have to debug that a bit later, because sometimes I think it needs a little bit of help. Anyway, right? Not too bad. Let me think really quickly about what could be happening. Okay, if you're off here, oh, if this is null, if it returns a null, yeah, if it's null here, then, so I could check is valid. Okay, if this is null, I can branch on this. And hey, if it's not valid, then what I could do is I could go false out of here and set it to red. Otherwise, I just continue out of here with true. Okay, I'll leave that as an exercise to the reader. You can get that working a little bit more consistently. All right, everyone, I hope you'll refer back to this recording. I hope this makes sense in spirit, okay? You didn't need to, hopefully my forehead's probably kind of messed up, but you don't need to understand everything I did today. In the following lectures, we're going to talk more in depth about how to program in Unreal and how to think about it and how to kind of act in that environment. But I hope the high-level spirit of what we're doing and why we did it makes a little bit of sense to you, okay? And this is a very nice, very fun, very friendly, and very fast way to add interactions to an environment. I think you're going to love it, and we'll see you next time, okay? Good luck with your Project 1. I will try and release your final teams later tonight after I'm done with game engine architecture, okay? So look forward to that and get started early if you can. See you later. If you're having trouble with the tutorial assignments, you've got 24 hours to submit late, and you can hang with me in office hours tonight if you want me to help you with that. See ya. Okay, everyone online, I will see you later. Take care, everyone. Bye-bye.